Guys, we're just going to do some example problems with work being done by a variable force. So I think this should be on y'all's study guide for exam 2. So we're going to get to this problem. But first, just a quick review. So we've talked about how in our book and in the homework, work done by a constant force is just given by the equation work equals the force applied on an object and the distance that that object moves, and the units of work is joules, which is the same as Newton times meter. So for example, if I had a force being applied to an object of 5 newtons and that object moved a distance of 3 meters, then to find that work, the work done on that object by that force, the work would just be 5 newtons multiplied by 3 meters, which would equal 15 joules. But what if that force is no longer constant that whole time? Then we have a new equation for work. Work then becomes the integral from a to b of f of x dx. So for a constant force, for the first example, if we have a graph where distance is on the x-axis and force is on the y-axis, then no matter at what distance, force is constantly that 5 newtons. So this is a constant force. But what if the force, if x is on the x-axis, so distance, and then force is on the y-axis, what if it behaved something like this? So now f is a function of x, and depending where the value of x, f will change. So let's do an example. So what if we have to find the work done on an object if f equals 2x squared and from x equals 0 to x equals 3. So if we set up our integral, that would look like work equals the integral from 0 to 3 of 2x squared dx. And then we would take that integral and that would be our work. So just how in this example, the area under this curve was our work, but it was easy because it was just like finding the area under a rectangle. You multiply the height times the width. Instead, now our whole work is going to be the area under this whole curve, which is also the integral. So to find the integral of this equation right here, this would just be 2x squared would become 2 over 3x cubed, and then we'd evaluate it from 0 to 3. Which would equal 2 over 3 times 3 cubed minus 0, because if you plug in 0 for x, that whole quantity would be 0. And then this would just equal 18 joules. So this is saying if you have a function of x, if you have a force that is a function of s, and it's defined by 2x squared for a distance from 0 to 3 meters, the work done from 0 to 3 meters is 18 joules. Okay, so now let's apply this to our homework problem. So this is a similar graph where it's saying that at each difference, the force value may be different. So it's saying the force acting on a particle varies, as shown in the figure below. And each of these ticks here is 0.5. So each of the larger ticks are 1 meter. So for part A, find the work done by the force on the particle as it moves across the following distances. So for part A, from 0 to 4 meters, which is 1, 2, 3, 4. So basically, we're trying to find the area under this triangle, and that's going to be our work. So in this case, it doesn't give us an integral to set up and solve. But knowing that this is just a simple triangle, we can just find the area under this curve, and that will be our work done from 0 to 4. So the area of a triangle is 1/2 times base times height. So for this example, be 1/2. The base is from 0 to 4, so that'd be 4 meters. And the height goes from 0 to 6 newtons. 6 newtons. So for part A, the work would be equal to 1/2 6 newtons times 4 meters, which would equal 12 joules. So that's where we get this. Okay, we'll do one more example. So let's go ahead and jump to part C, because B is very similar. For part C, we're going to have two different triangles. It says from 0 all the way to 6. So if we go, so let's erase my highlighter from last time. So now from 0 all the way to 6, we have the area under this triangle and the area under this triangle. So we're just going to add those two triangles up. And remember, this is coming from the definition of work being the integral of f of x dx. And the integral is just the area under that curve. So that's why we're taking the area of these triangles. So work here, oops, not J, W is going to equal, we already found the area under this curve. And so that's 12 joules. So that's 12 joules plus the area of the smaller triangle, which is going to be half times the base, which is 2 whole meters, because it goes from 4 to 6, 2 meters, and the height goes from 0 down to -3. So now we have a -3. So now this is going to equal, work equals 12 joules plus 2 times negative 3 is negative 6 times half is negative 3 joules. And if we add that up, that would be 9 joules. So that's where we get this 9 here. I hope this helps. Email me with any questions at all.